Hi, I am Saad Hassan from Tulane University, and on behalf of my co-authors from Gallaudet University, Rochester Institute of Technology, Google, and Deaf Professional Artists Network, I will be presenting this work titled Tap to Sign Towards Using American Sign Language for Text Entry on Smartphones. There are over 70 million deaf and hard of hearing individuals in the world. Increasing numbers of people who are deaf and hard of hearing, as well as some hearing individuals, use one or more of around 150 sign languages to communicate. In the US alone, American Sign Language is used by around 500,000 individuals. With the advent of some smartphones and being able to communicate on the go, some deaf users have begun altering their signing styles while using smartphone cameras, a phenomenon we refer to as smartphone signing. When ASL signers are engaged in video calls while mobile, it is typical for them to hold their smartphone in one hand and sign using their free hand. In a recent study, 53% deaf users reported holding their smartphone in one hand while signing using the other. Interactions with mobile assistants is one of the most requested feature by deaf and hard of hearing community. While sign language recognition has been a topic of interest by machine learning community for decades, most systems have little usefulness or usability for the deaf community. Fingerspelling should be easier to recognize in theory, but more attempts have been technical demonstrations instead of working towards a goal that might be helpful for the deaf community. In the studies presented in this paper, we had two goals. We wanted to evaluate whether a significant data collection effort for fingerspelling is justified by identifying a practical application for a fingerspelling recognition system, namely text entry on mobile phones, and testing an emulated version of that application with the deaf community. Secondly, we wanted to examine the desirability of creating a recognition system for an additional but closely related subset of American Sign Language, signs that could be used to command a mobile assistant. We designed a mobile app called Tap to Sign that emulates fingerspelling recognition of an entire sentence at a time. The user had to fingerspell the entire prompted sentence before being given feedback on what they signed below the prompt. Since recognition was emulated, the correct phrase was shown no matter what the user signed. No partial recognition was shown. Participants could press the undo icon to erase the entire sentence. Participants could see their average speed so far and the texting rate for the last phrase. Participants signed a total of 1,000 phrases taken from a standard text entry dataset using this interface. We designed a second mobile app called Push to Sign that emulates recognition one word at a time, requiring the user to hold the recognition button while fingerspelling each word and releasing between words. This would provide recognition advantage as the recognizer would just need to recognize one word at a time. Recognition was still emulated by always showing the correct next word in the sentence. Participants could still undo if they felt that they signed incorrectly. Deaf participants were recruited by a deaf professional organization. Smartphone texting is prevalent in the deaf community as a way to communicate, and these participants were already expert in using texting interfaces. For an accurate comparison between texting and fingerspelling, we first needed to train our participants to expert levels with our fingerspelling interface by collecting several hours of fingerspelling phrases, which led to our first research question. Our first research question was, how much training is required to reach expertise in fingerspelling text entry interface? To answer this question, we conducted a study with 12 deaf participants who fingerspelled 1,000 phrases using Tap to Sign interface. We found that the participants' speed increased over time as they captured 1,000 phrases fingerspelled with the Tap to Sign app. This learning curve was a bit surprising in that we had assumed that fingerspelling phrases would be straightforward for people who used ASL as their primary language. However, fingerspelling is normally used in bursts in communication, so some training period proved beneficial both to learn the interface and to reach proficiency for fingerspelling at speed. Next, we wanted to compare it to push to sign and virtual keyboard. Our second research question was, are the tap to sign and push to sign fingerspelling prototypes faster and more preferred for text entry versus a virtual keyboard for deaf users trained to expertise with the fingerspelling interface? To answer this question, we ran an experimental study split in 3 sessions in which participants interacted with the 3 different text entry approaches for 5 minutes each during each session. We designed another third interface to emulate the fingerspelling typing. Participants could see individual characters being typed and autocorrect was available. Predictive text was, however, turned off. Our participants fingerspelled faster using tap to sign and push to sign as compared to virtual keyboard. Surprisingly, participants fingerspelled fastest using push to sign interface, even though they had just fingerspelled 1,000 phrases using tap to sign. This could be attributed to the difficulty with signing English prompts. Deaf users may have difficulty with English spellings as the gestures in ASL have little to no correlation with English. In the paper, we also report error rates and other metrics that consider speed accuracy trade offs, such as bandwidth and throughput. Across all these metrics, the two fingerspelling conditions performed better. The results of NASA TLX questionnaire administered after each session indicated that although participants performed better using the two fingerspelling prototypes, their subjective workload was higher, especially in case of push to sign. The same was true for responses to subjective questions related to usage experience and comfort. In a final survey, half of the participants indicated that their top choice would be tap to sign, whereas the other half said virtual keyboard. A closely related application domain for fingerspelling recognition is commanding a mobile assistant, a personal assistant on a smartphone. Many mobile assistant commands will naturally involve fingerspelling for proper nouns such as contact names and location. The commands themselves are relatively limited in number and scope by assistant's capabilities. In the next study, we investigated whether fingerspelling these commands would be an adequate first interface or whether the system needs to recognize signed commands as well as fingerspelling in order to be accepted by the deaf community. Our last research question was, in a walkable usability evaluation, do deaf users prefer fingerspelling and/or smartphone signing for text entry over typing on a virtual keyboard to command an emulated virtual assistant? To answer this question, we conducted an in-the-wild experimental study with 12 deaf users at a deaf conference. We designed 3 emulated mobile assistant interfaces. The first one used a tap to sign interface that allowed participants to sign short personal assistant commands to a mobile phone and see results. They were allowed to use signs wherever possible in addition to fingerspelling. In the second condition, which also used tap to sign, they were asked only to use fingerspelling. Finally, in the third condition, they were required to type the phrase to command the mobile assistant. Participants gave feedback using a survey. The findings showed that smartphone signing prototype that allowed participants to use a mixture of signing and fingerspelling, as well as the virtual keyboard, were considered more natural and preferred over fingerspelling only interface. In the paper, we also report other performance metrics which also indicate that smartphone signing and virtual keyboard performed better than fingerspelling only. In open-ended interviews conducted at the end of the study, participants provided several suggestions for using mobile assistant capable of taking signed input, spanning navigation, communication, information access, device control, and other personal use cases. Participants expressed their excitement towards mobile assistants, provided feedback and suggestions for new features, and also pointed out some concerns. To conclude, our research indicates that user speed and preferences in using fingerspelling for text entry improve over time with acclimatization. Study 1 demonstrated that with experience, 50% of participants favored fingerspelling. Study 2 revealed that users prefer signing and virtual keyboards over fingerspelling when interacting with a mobile assistant. Fingerspelling recognition does seem to be a worthwhile endeavor for sign recognition efforts for interfaces where the user can be enticed to gain sufficient experience with the interaction, or as a part of a more general signing system for interacting with a mobile assistant. Thanks for listening.